Hi, everyone. Thomas Logan here, one of the crew of ID24. Really happy to be with you all and invite you to the session this hour. So I've been going about 9 hours today. We've been to Japan, India, Australia, Finland, and now we're in the United Kingdom. So it's been an awesome day so far. Really happy to have you joined with us. We want to thank and appreciate our partnership with our Platinum supporters, Intopia, Fable, Arc, and Adobe, and our gold supporter, Tetralogical. You can follow us on Twitter at ID24Conf, that's CONF. And if you have questions for the presenters, you can tweet them using the hashtag ID24 on Twitter. And we'll be monitoring that and be able to ask those in the Q&A section at the end of the session. And now I'm thrilled to be joined by my guest host, Rachel Andrew. Over to you, Rachel.
Hey, hello. Back in my shed in the UK, and I've just learned that our next presenter is also in a garden office. So the Brits are coming to you direct from their sheds. So I'm really happy to bring you Simon Hearn, who is going to be talking about how inclusive design is fast by default, and so why performance is really important when we're building an inclusive web. Simon's a highly regarded web performance architect based in Surrey in the UK. He's passionate about great user experience and has spent the last 10 years helping some of the world's biggest websites to deliver fast and inclusive user experience. Simon has a background in artificial intelligence, web engineering, and technical consultancy. So I shall hand you over to Simon, and inclusive design is fast by default.
Thank you so much, Rachel. And thank you to the audience for joining me at ID24. I'm Simon Hearn, and for the next 40 minutes, I want to talk about performance and why it's critical to online inclusivity. And before we do that, I want to propose a thought experiment. And I know what you're thinking, you didn't join an online conference to think, but just give me a few seconds. And I'd like you to think about the last time you had poor Wi-Fi or cellular connectivity. Last time you really struggled to get a connection. It may not be too recent. For me, being in a shed, which is actually a steel shed, so it makes a very effective Faraday cage, just a few weeks ago, my cable internet went out. Because of this Faraday cage effect, I rely on Wi-Fi calling. So when my internet went out, my 20 kilobit per second 3G connection did nothing. I couldn't load websites, I couldn't use WhatsApp, I couldn't use Twitter. It was quite nice, actually, a little break. For me, that outage lasted about 20 minutes. And when the internet came back, messages started flooding in, web pages started to load instantly-ish again. And pretty soon I'd forgotten about that blip in my internet connectivity. But during that time, I was instantly, temporarily excluded from the internet. And it felt quite strange, something which I rely on pretty much every minute of my waking day. I couldn't complete work tasks, I couldn't check my emails, and even though my phones reported some signal, they were totally useless. And this is a challenge that I had for 20 minutes in a kind of a privileged position. Because in the UK, we treat connectivity as a utility, and you probably do too. Just like gas, water, and electricity, you just expect it to work. When it stops working, that's a pretty major issue. The chances are you are in a similar situation to me. You have a reasonable internet connection at home. You may have access to an office which has a great internet connection, and you probably have a smartphone which is reasonably modern, well specified, and has 4G or maybe even 5G, and a big processor to get through expensive JavaScript tasks. So for us, internet's like a utility, but for many folks, it's not. So this probably isn't a surprising statistic that 65% of the developing world doesn't have consistently fast access to the internet. What may be more surprising is that 20% of the developed world doesn't either. And what I want to talk about today is how, well, we're talking about inclusive design, and I would like you to consider how performance, so the speed of our apps and websites, is critical to inclusivity and access. to illustrate this point, I want to go back to 2009. YouTube had a web-based player based on Flash. This was 2009. And the web player, even before you downloaded any video content, was 1.2 megabytes. Nowadays, it doesn't seem so big, but back in 2009, before really 4G had rolled out, this is a big page to load over mobile network. Now, there's a story from Chris Zacharias, who was working on the YouTube web project, and he noticed how slow the player page was to load. 1.2 megabytes of content before the video even started to load. So he worked on a project to improve this performance called Project Feather. The engineering work was intense, handcrafting CSS, HTML, and JavaScript, removing the Flash player and implementing the newly standardized HTML5 video player. The result of this work was pretty incredible. The player page dropped from 1.2 meg to 100 kilobytes, and from over 100 requests to just 14. So quite an improvement. Testing and development showed that this page was fast, much faster than the old heavy Flash-based player page. So it was pushed forward to a small opt-in experiment for real YouTube visitors. The goal was to collect performance data for a couple of weeks and to see how good or how big the performance improvement was. Take a second to think how much you think that would improve in the real world. So dropping 1.1 megabytes of content, expected to be quite significant. Maybe a 50% improvement, maybe a 60% improvement. What actually happened was it got slower. So the real user data from Project Feather showed that loading that page took longer on average than loading the heavy 1.2 megabyte Flash player page. So this led to some investigation. And what Chris found was that when they made the page faster, it opened it up to a huge number of visitors who had never been able to load the YouTube player page before. And what happened was this traffic came from places with poorer connectivity. Even now, if we look at the performance of the mobile YouTube player page, we see a great disparity between more developed nations, where we can see US, Canada, Western Europe, and Australia all come up green as measured by largest contentful paint being less than 2.5 seconds, Google's Core Web Vital metric. Where we see it being a little bit worse is Eastern Europe, South America. Where we see it the absolute worst is in Africa, Iran, Afghanistan, and Turkmenistan. Now, it's kind of easy to understand why that might be. And if we dig into the data, we can see the connectivity differences between these countries is huge. In this world map, darker colors mean a greater proportion of 4G connections. But when we talk about 4G in the Chrome Real User Experience report, the data that Google collects from real browsers, it's not talking about a 4G connection. It's talking about an effective 4G connection type. And actually, that means anything from infinitely fast down to 700 kilobits per second. So the countries with dark colors here, on average, have more people who have a connection greater than 700K. Where they are white, there are 0 connections that are, on average, faster than 700 kilobits per second. And we can see why there's this direct relationship between the availability of good network connections and the speed of the pages that visitors are trying to load. Looking at it geographically is kind of easy, but what we need to understand is that performance is a distribution. Even if we focus on mobile, US, loading the mobile player page, we can see there's a wide range of experiences. Again, looking at largest contentful paint here, you can see the 75th percentile was just over 3 seconds, which is pretty slow. 3 seconds is the golden number in performance, but the distribution has a long tail. And hopefully you can see over here, there's a significant number of people that have an experience slower than 15 seconds. So it's important to understand that not everybody has the same experience. Cloudflare recently did a study of actual download performance across the world. And even when we look into regions within the US, we get variation from the West Coast, about 100 megabits per second, actual download speed, down to 5 megabits per second or less in different regions around generally Central America. Which means you can't assume that everybody has the same connection. And the people who have the worst connections have the worst experiences. But we can do things to fix that. So the question I ask myself is, was Feather a success? And of course, by the numbers, it wasn't, because it got slower. But in reality, it was a huge success. It opened up YouTube and the educational, entertainment, and informative content to millions of new users who hadn't been able to access it before. So I'd like to think we can learn a few things from Feather. One is that being faster by default is more inclusive. It includes more people into those experiences. But also, performance data can be misleading. And it's one of my biggest challenges as a performance consultant is every tool gives you different numbers. Every user has a different experience. So it's hard to put a pin in exactly what the experience is. But to think about why people might have a bad experience a little bit further, there are huge numbers why people might have low quality internet. For me, my internet went down, my cable internet went down, and my Faraday cage box prevented me from using mobile internet. But 1 in 2 US households have no broadband connection, no cable internet. So they rely on mobile, which, as we know, is quite variable in quality. 15% of the UK population has no 4G coverage, so stuck at 3G speeds, which can be as slow as 100 kilobits per second. There are recently a significant number of natural disasters have been occurring, and those natural disasters often take out power lines and often take out internet infrastructure, which can mean people have a really limited ability to access things online when perhaps it's the most important time for them to do so. And due to a certain political event, next time I go traveling in Europe, I will be paying roaming charges for all the data I use. So I will be doing everything I can to reduce data consumption, turning off data entirely and using it only when I have to, and watching carefully how many megabytes I use, not gigabytes, how many megabytes I use, because that's what I'll be charged by. And if you let your phone go below 15%, you'll likely find your experience gets a little bit worse. That's because your phone will start to turn off the mobile radio quicker. It will throttle your CPU, which means rendering images, parsing and executing JavaScript will get slower. So the experience gets worse. And it's easy to forget that while we may be in a privileged position to be able to get credit, to get a contract, to get a modern device, a lot of folks cannot get credit, can't go to apple.com and order an iPhone 13 Pro. So they'll be stuck on a device which they bought for $100 maybe a few years ago. What's really important is how many of these do we experience when we're designing or developing an app? I think our privilege kind of leads us astray in that it works for me, becomes it's fast for me, and yet there may be a huge amount of people who have a worse experience, which is invisible to us. And when I say this to my clients, I often get a response, but our data shows. And this is where analytics data can be really tricky. Analytics data is good for general analysis and marketing information, but we have to be aware of things like survivorship bias. Users who never actually load the page, such as in the YouTube player example, don't appear in analytics. If it takes 5 minutes and they give up after 4, they've had a bad experience and your data doesn't show anything. More recently, we'll start to see analytics being blocked. About 90%, almost 90% of Firefox users block Google Analytics and other analytics providers. 40% of Safari users do. And there's 40% more tracker blocking in the developing world than there is in the developed world. So your bias or your lens on the data is focusing on a small subset of users. And if you're using the Chrome Real User Experience report that you get in Search Console or PageSpeed Insights, that data is only for Chrome. And it's only for Chrome on Windows, macOS, and Android. Notably excluded is iOS, because Chrome isn't Chrome on iOS. There are a huge number of reasons why not all of your users are represented in your data. So we have to bear that in mind when we're thinking about how to make things faster and whether we should be making things faster. So for the rest of this presentation, I want to talk about how we build fast, inclusive experiences. And I'll do that in 4 sections. Understanding the problem, how we design for speed, how we adapt to the user, and how, perhaps most importantly, we convince the boss or our stakeholders that we should invest in performance. So first off, we need to understand the problem before we can solve it. Now, users aren't averages, and this tweet came out from Ryan Townsend last week, where he was on a MacBook Pro M1 in a business class lounge, and yet the Twitter app, web app, took 30 seconds to load. And when we look at averages, we kind of exclude these edge cases, which people experience every day. So we need to understand not just the average experience, but how we bring the long tail of the distribution to a faster experience. Now, metrics are getting better for us to measure this. Google has been kind of pioneering here with Core Web Vitals. And if you load PageSpeed Insights, this is for m.youtube.com, you'll see a whole slew of data, and it can be a bit confusing. So just to clarify things a bit, the score at the top, 35 for YouTube, is measured from this test using a synthetic agent, emulating a mobile device, and speed metrics are used to aggregate up into a score. So while going for 100 is good, this doesn't reflect real user experience. What we have now are Core Web Vitals, which are better proxies of user experience. You may have measured DOM content loaded or the onload time before, but largest contentful paint, first input delay, and cumulative layout shift are all somewhere between performance and UX and give us a good idea of the quality of experience we're delivering. To that end, when you see field data in PageSpeed Insights or Lighthouse Audit, this is taken from real users. And the value that's collected is the 75th percentile. Because like I said, performance is a distribution, and measuring the average is kind of meaningless. The 75th percentile is somewhere between the median, which is hard to change, and the 95th percentile, which varies a lot and may not be meaningful. And important to note, lab tests in PageSpeed Insights are tested on an emulated Moto G4, a budget phone that was released a few years ago on a 3G connection. And that's why the numbers might not feel right to you. They might look a little bit slow. But a lot of your users might be using that particular device and connection combination. Another tool that I spend a lot of time in is Web Page Test, or WPT. And here you can kind of copy those settings. So set my device to Moto G4 and my connection to 3G fast. Now, Web Page Test has a huge amount of data and detail in it. But some of the really interesting things are the fact that it now compares your test results in black on these budget bars with the real data collected in the field by Crux. So you can see how relevant your test was to what your users are experiencing, again, on Chrome, excluding iOS. But one of my favorite features, which is relatively underutilized, is this cost column. It shows you approximately how costly this page was to load. And if you click on it, it goes through to how much does my site cost.com, or what does my site cost.com, and it uses aggregated data about mobile data costs across the world to work out how much in real money it would cost someone on a prepaid contract to load that page. What always surprises me here is that Canada and Japan have more expensive data than Botswana, and India always comes out as the cheapest. So just because your site is fast in a developed world doesn't mean it's cheap for users to consume their data bandwidth, data budget. Another tool that I use quite a lot is Trio. Trio uses the data behind Core Web Vitals, behind the page experience update, but it allows you to see how your data is trending over time and allows you to compare it with other websites as well. So here I've got YouTube on the left, Vimeo in the middle, and Dailymotion on the right. And if I was looking at this and I was Dailymotion, I think we really need to improve our performance because at the 75th percentile, we are 5 times slower than YouTube to get the most important content painted to screen. So my first tip is to use the tools. There are literally hundreds of performance tools available, and unfortunately they all give slightly different numbers with slightly different context. So my tip is to choose a few, at least one lab tool like Lighthouse or Web Page Test, and one real user tool, something like Akamai's Impulse, which can give you the balance of being able to test in development, but also to collect real data from real users to help you make decisions about what parts of the site need to be improved. So if we know how to improve, we know we need to improve, let's talk about how we do improve. And there's a bit of a sneaky tip here. Recently, there was, well, relatively recently, Hurricane Ida went through Louisiana. And NPR released an article about how long it would take for power to come back, what was happening with emergency services, and information that might be critical if you were affected by this hurricane. Immediately below that link to the article, they also put a link to a text-only version of the site. So if you were browsing this and you were stuck in Louisiana with no power, you could view a text-based website which would consume less energy from your device and maybe keep it running a little bit longer, which is important in an emergent situation. And NPR isn't the only website that does this. There's a GitHub repository called Awesome Light Sites, and it lists all the different websites which have a light version, a text-only version, either first party, like NPR doing their own, or third party, like Hacker News having an API which is used to make a text-only version. But the title of this talk was An Inclusive Web is Fast by Default. And I don't think having a light version is fast by default. In fact, it's almost an admission that your main website is too slow. So it's kind of like a get out of jail free card. It's better than nothing, but I think we should work towards delivering fast by default experiences. To that end, performance must be baked in. And that's the reason that I wanted to talk at ID24, because performance starts with design. We often leave performance too late in the process. And if we consider a simplified project timeline, which I borrowed from Katie Kowalczyn's talk, The Path to Performance, we often think that performance happens at the end. We deliver a UAT version of the site, someone complains about performance, and it gets fixed and released to production. But where performance really needs to happen is right from design, right from working out how we're going to build the page. We need to know how to do that in a way that will be a fast experience. A simple way to think about this is it's widely understood that bugs get more expensive the later they are discovered. And the same is true for performance issues. Except with performance issues, they may not be fixed at all if they're discovered late in the process, which is why it's so important to get it done and get it right early. Patrick Hammond worked at The Guardian, and one of his projects was to improve the performance of The Guardian's article pages. The Guardian is a print and digital newspaper in the UK. So from his talk, Breaking News at 1000 milliseconds, the key concept was progressive enhancement. To be able to know from the design stage which parts of a page are critical to the user experience. So from a news article perspective, that's the headline, the body text, and then the hero image. Then everything else should be delayed until the user has had the time to experience the page and consume the content they want to. Then if the browser supports web fonts, we can load those in, and we can load adverts in to generate revenue, and we can add things like recommended articles later because they're lower down the page and they're less important from a user's perspective. So let's talk a bit about some of these concepts. Images make up about 50% of the average web page. I don't like averages. Your website may have no images at all, but in general, images make up the most in transferred bytes for a page. The average mobile page has 1 megabyte of images. So this is a really good place to start trying to improve. There's a load of things we can do to improve, such as not sending images which aren't visible, such as giving low quality placeholders to give time for the user to consume content while loading in the full image. The web world has improved hugely in terms of formats. We've got WebP, AVIF, Hike, and Hive, which allow us to deliver the same quality image, but with fewer bytes, and delivering the right-sized image. Responsive web design is a well-established paradigm, but responsive images are still tricky to implement, and a lot of websites don't do it. Now, next in terms of bytes is JavaScript. And what's concerning about JavaScript is the cost of a JavaScript asset is, for 1 megabyte, say, is more than the cost of an image that is 1 megabyte. That's because not only does it have to be downloaded over the network, it has to be parsed and executed by the browser. And the time the browser spends parsing and executing can often be longer than the time it took to download the file. So we should do everything we can to reduce our dependency on JavaScript in the browser. There's loads of modern features which replace things that we may use jQuery for. There's great client-side JavaScript in ES 2015, and we should be measuring the impact of this part of our website on real devices, because when you emulate, it's really hard to judge the actual impact of heavy JavaScript. Now, painting fast. The most important thing for a user is to see something on the screen when they've clicked a link. And there's a few tips to deliver that content quickly. Don't depend on video is my first one. And I won't tell designers not to use video, but you can't assume it's going to load quickly. So either have an image that's replaced with a video, or use the built-in HTML5 video. I forget the name of it, but you can show the thumbnail first. At design stage, we should understand which components of the page are critical to render. And then at the develop stage, we can take the CSS for that, inline it into the HTML, and then lazy load or asynchronously load the rest of the CSS bundle so the page can render with just the HTML downloaded. That will have a remarkable effect on the time it takes to paint that initial view. And then there's technology such as preload, which is a way for us to tell the browser to go and fetch an asset as quickly as it can, but without blocking render. And we can prioritize key assets like images with the new loading attribute, which we'll talk about a bit in a second. All of this it might be mind-blowing. There's so much to take care of, but tools like PageSpeed Insights can help. So here in the opportunities and diagnostics views, we have where the time is spent and advice on what we can do to improve the load time of these pages. There are loads of other tools which help to do this as well. And there's a few more links in the slide deck, which is tweeted out by me earlier on. Okay, so how do we adapt to the user? Assuming we can deliver a reasonably fast experience, there are a few things that users can do to ask us to do things differently. Something you'll be aware of is dark and light mode based on the operating system preferences, but there's also something called light mode. Light mode is a toggle in Chromium-based mobile browsers, and it's a flag that the user sets to say, I want to save data, something that I would use if I was traveling and had to pay for every megabyte of data. One of the ways that Chrome uses this is to pre-render pages and cache them in Google servers. That's not ideal, and you can opt out of it. But the other thing it does is sets a request header, so that when the browser requests a page, it says to the server, I'd like a light mode, please. And you could use this as your switch to go to a text-based version, or to reduce at the server level some of the heavier content on the page. For example, sending smaller images. Data Saver also appears in the Network Information API. This is available in JavaScript through navigator.connection, and it gives us an object with the download speed estimated for that browser, the latency, the effective connection type, which is almost always 4G, and save data, whether it's true or false. So in your client-side code, you can observe this and do something different based on it. A bit like reduced motion or theming. And finally, we've got client hints. Relatively well supported, if your server responds to a request for a page with an accept CH header, including, say, downlink, width, and DPR, when the browser makes future requests, it includes that information as request headers. So for images, this gives us a great way to automatically deliver the right-sized image at the right DPR. In this case, 1,000 pixels, 1025 times 2, we should deliver a 2050 pixel image. Although if the device had a low memory or a poor downlink, we could adapt and deliver a lower resolution image. Speaking of images, it should be more simple than it is. My recommendation is to use a service to resize and to get modern formats. It's just too much work to try and generate all the different variations of widths and formats to get a satisfactory result. And there are services that do that better than you probably could. Akamai has got Image Manager, there's Cloudinary, ImageX. Every CDN has some kind of image optimization service, so it shouldn't be difficult or expensive to do that. Then we need to use markup to deliver the right image. And this is where most people kind of fall over, because just having a service to send the right image is half the battle. We also need to get the browser to request the right image. And something you might find with newer Android devices with really high resolution displays is they'll send a 4x or a 3x DPR, which means they'll request an image 4 times bigger in image pixels than it's going to be displayed in CSS pixels. If you can cap that at 2x, you'll deliver the same experience, the same quality, but with far fewer bytes. So I've got a quick example here of how responsive markup might look. You have your source for browsers that don't support source set. You have an alt, which should be filled in. And then there's 2 attributes here, loading equals eager and decoding equals async. Loading equals eager tells the browser that this is an important image. So it might be a hero image on the page. The alternatives are auto and lazy. So images that are in a meganav or below the fold should have loading equals lazy. And then the browser will load those images at the right time, as they're coming into the viewport, or when the browser's idle and has some bandwidth to spare. The width and height attributes are really important, and it's kind of confusing. This doesn't have to be the width and height of the image on the page. It needs to be the intrinsic size of the image, just so the browser can calculate the aspect ratio. And then when it knows the width of the element that the image will be contained in, it can also allocate the relevant height, so you don't get a layout shift when that image is first downloaded. Now, the next 2 important things for this way of loading responsive images are source set, and that tells the browser how to fetch different sized images. With an image service, it might be through a query parameter or a long string at the end of the URL. In this case, I'm saying there's a 600 pixel wide image at image 600, and the normal one is 1920, with some in the middle. But the browser needs to know how big the element is going to be on the page, so it can request it before it's built the DOM, built the page. And that's where the sizes attribute comes in. And this is where design is really important, because the size as attribute tells the browser what the different viewports are, or the different breakpoints are on the viewpoint, and what size the images will be. For example, a wide viewport may have a 3 wide grid of images, narrow might be 2, and super narrow might be 1. The sizes attribute allows you to tell the browser how the images are going to be laid out, so it can request the right size for the right viewport width and the right breakpoint. There's loads of resources out there on how to do this. It is not easy, and it's not easy to test, but it's really important to get right. Now, another thing I've borrowed from Katie Kowalczyn's talk is this slide on performance budgets. Performance budgets can be set at the design stage. Say we should be able to render this page with 400 kilobytes, say. And you could base this budget on previous projects or the existing application that you're replacing, where you have an amount of data that you can't spend more than. You can't spend more than 400 kilobytes rendering this page. So the point at which your JavaScript gets to 200 kilobytes, you either need to reduce the JavaScript payload or swap something else out, like using system fonts instead of web fonts. Performance budget is a really powerful tool to communicate from the very beginning of a design process right through to deployment, how the performance should be measured in a kind of a static environment. And it doesn't have to stay the same, it can evolve over time, but it's a great single source of truth for everyone to come together on to make sure that performance budgets don't explode over time. And one last thing I want to cover is A/B testing, because everyone loves A/B testing. It's a great way to measure and improve the performance of a website, especially in the e-commerce retail space. Unfortunately, it's often a performance nightmare. So where possible, use server-side tooling. So doing A/B tests through a service or at your server or CDN rather than in JavaScript, because the way JavaScript A/B testing works is to hide all the content until it's decided what to show, which is not good. And then separate production and pre-production tests and remove unused tests, just to make things a little bit quicker. And I probably shouldn't need to say it, but don't have 100% tests. So I've seen some clients that have 100% tests where they are actually modifying the website using the A/B testing tool rather than putting tickets through the development process. That's a good shortcut to get things done, but can lead to disastrous performance effects. So the key takeaway from this is performance works best when it's understood from design forward. It's really hard to retrofit performance into an existing project. It's certainly possible, but it takes longer and costs more and is harder work than getting it right at the beginning. All right, on to the fun stuff, convincing the boss. So by now, I'd like to think that you're all convinced of the value of improving speed. Unfortunately, some of us need to convince others as well. Performance as a topic is often underfunded unless or until something goes wrong. So for example, the CEO tries to load the page from a train and it goes slow, and then sends a message to someone to say, why is our site slow? It's often hard to convince people of the value of performance. What does 10 milliseconds mean? What does 100 milliseconds mean? And it's very tough to build that case study. Thankfully, there is an open source repository of case studies on wpastats.com, which is just a list of hundreds of stories where people have improved performance and seen some kind of business gain, be it conversion, page views, SEO. Almost every time you improve performance, everything else improves. Even if it's just by a small amount, you may be moving people from that tail end of the distribution a little bit faster, and they're more likely to do the things that you want them to do. Read another article, buy another product, go to another blog post on your site. So I've got a list of very factual buy-in methods that I've seen work in the past. If you say please a lot, there's about 10% chance of you getting the budget and time to work on performance. Not ideal. If you use global statistics, like some of those I used at the beginning, you might drive up a bit of interest and get buy-in. If you use your own data, you're much more likely to get buy-in, but it's still quite hard to see the link between performance and the business outcomes. If you just say SEO repeatedly, that works about 50% of the time. Historically, the link between performance and SEO has been quite hard to pin down, but with the page experience update, at least we know that on Google search engine results pages, performance has a direct relationship with ranking. You get a ranking boost if you are fast. Who wouldn't want that? And then for a 60% chance of success, unfortunately, it's appealing to people. Competitive benchmarking, show how you're faster or slower than your peers or other competitors in the marketplace. Ideally, you want to be 20% faster than the next peer website. That's when users will start to notice a difference. A little disclaimer, the numbers may vary. I didn't get them from a proper study. But seriously, getting buy-in is really difficult, especially after a project starts, especially if it hasn't been budgeted for or time allocated. So speed should be included in proposals, early designs, and the success criteria for a project. That's the best way to ensure a successful outcome in terms of performance and inclusivity. Now, finally, I want to go back to empathy. At the beginning, I said, most of us in this environment don't experience awful internet every day. But there are some tips that we can use to improve our empathy with folks who do. One is if you're a Google Chrome user, other browsers have similar features. You can open the developer tools, go to Performance tab, and emulate a slow CPU and slow network. When you try to use this, it may feel painfully slow, but there are people out there who have that experience every day. And if you're browsing one of your designs or one of your early prototypes using these features and it's impossible to use, that's a good indication that there's some room to improve, opportunity to make things better. Something that Facebook did a while ago was implement 2G Tuesdays. So the office Wi-Fi at Facebook on a Tuesday was slowed down to 2G speeds, so sub-megabit. In fact, I think it was about 200 kilobits per second network connection, which forced everyone to have a feeling for how hard it is to use applications on slow networks. Now, I'm not recommending you turn your office Wi-Fi off, but every now and then it can be really interesting to see what the web feels like through the eyes of a very slow connection. And something that always surprises me is when we tend to test on modern devices, because our analytics shows that most people pick up, say, an iPhone within 2 years of release. But not everyone has an iPhone 13 Pro or has the ability to buy one. The 6 most popular prepaid phones on Amazon yesterday were all Android devices, the majority of them under £200. The most expensive in that top 6 is the Pixel 4a, which was released over a year ago as a budget phone. So the majority of people buying prepaid phones, at least from Amazon, are buying cheap, low-end devices. The great thing is it's cheap for you to buy one and use it for testing. Browsing with JavaScript disabled is really interesting. Either your website doesn't work, such as Twitter, or your website is lightning fast. Either of those gives us a good indication of things that we could improve. If your website doesn't work without JavaScript, that's an issue because a few people, or a lot of people, browse without JavaScript enabled because it makes the web faster and uses less data. So if your website gets really fast with JavaScript disabled, it lets you know that there's a bottleneck in your JavaScript, and that should be where you should be focusing your optimization efforts. And finally, test with third parties. Oftentimes when we test for performance, we're testing in a pre-production environment where the tag manager isn't enabled, where the marketing cookies aren't there. If we test without third parties, we're not testing the full experience because that's not what customers experience. So ideally, we should do all performance testing with the full stack of third-party content. It's not always easy, but it's worth doing. There's also a load of tips around third parties, such as, did you know you can use Google Tag Manager and Google Analytics without any JavaScript code at all? Ideally, we should remove third parties that have a high cost on experience and JavaScript weight. I know it's not always easy, but if we have a third-party budget, it can be a little bit easier. So we only want to spend 1 second of JavaScript execution time on third parties. So when someone says we're going to add this marketing script, if it exceeds the budget, then it can't be added. Again, not easy, but really valuable to do. So if there's one takeaway, performance is about empathy. It's about understanding what people other than us experience the web like. The future is already here, it's just not evenly distributed. And I think that's really true when it comes to the web and the way we experience it. If that doesn't get you interested, then there's also a load of opportunities for speed. Here, Amazon India Retail is looking for someone who can help them build a faster experience, especially for users with high latency, low bandwidth connections. So big enterprises care about this, and you should too. Now, I could talk for 24 hours myself on performance. Unfortunately, no one would be interested in that, but there are a bunch of resources. Here are 5 books I would highly recommend. Also in the notes on this slide, there's a link to another 18 books. So there's certainly a lot of literature out there. Also hundreds of blogs, articles, Smashing Magazine has got a bunch as well. So there's plenty of support out there to help you build inclusive, fast experiences. So with that, I'll say thank you and good luck with designing and building fast experiences.
Thank you, Simon, so much for the excellent talk, and definitely got me thinking about how little you think about the inclusion, especially when you were showing the maps of the world and thinking about how connection speeds don't get displayed in a lot of the reports that people even look at to make these decisions. So yeah, learned a lot. Thank you very much. Rachel, do we have any questions for Simon?
Yeah, that was really interesting, and I think it's fascinating as to there's a real sort of correlation with accessibility, inclusion, and performance. I think both from the things that help with inclusive design and also performance at the same time, but also in terms of getting buy-in and so on. I mean, I saying SEO repeatedly will, because I think that's always been the way. I mean, I've been doing this for 20 odd years, and it used to be the way to get people to be accessible. Like, oh, but it also will help you SEO. So yeah, that's it's interesting. Some things never change. So yeah, so questions. The global map of internet speeds and country comparisons. Does that tend to mean that high-speed internet is not available in that country, or is it just that people aren't purchasing that? Are they tending to purchase lower speeds?
Yeah, so you can look at global stats to see the deployment of 4G networks, and they correlate really well with those actual connection speeds that people use. I think there's so many factors there, such as, can someone afford to buy a 4G device? If there's 5G deployed, can someone afford a 5G contract, which may be more expensive? So in general, it's hard to look at averages, but Yeah, and there's poorer deployment of high bandwidth networks in less developed countries.
Yeah, I think it's always, I think people like to have sort of precise data, don't they, to sort of to hang off. But yeah, it's sort of just that those kind of averages, I guess, is what we're looking at. So something else, and this kind of goes back to sort of these conflicting priorities that we might have if we're working on a site. Have you ever had to deal with a client who doesn't want to add, say, accessibility attributes to images because they're like, well, that's some extra code, we don't need to do that, and that'll reduce the page load? The comment was that in the past with Flash, people used to turn accessibility off by default so that the people weren't having to deal with the performance implication of that. So have you ever had that kind of conflict between performance and things that would be helpful to add?
I have, but not with the alt attribute. So in terms of bytes, that would be really tiny compared to everything else. I think a different compromise we see is that if you wanted to get every breakpoint represented in your image source set attribute, that's a lot of content, especially if you have 30 images, 5 breakpoints, and 6 derivatives of each image. And it's a problem that's yet to be solved by web standards. But I don't think I've ever seen anything in the web where accessibility conflicts with performance. If anything, it's the other way around. You want to get the DOM on screen as quickly as possible, so the accessibility model can be built as quickly as possible.
Mm-hmm. So it's sort of thinking about, so sort of, I think if people are looking at this and maybe they're just making their first steps into trying to make things more inclusive, to make things faster, to make things more performant, what are kind of just the top things to look at? Where do you start? Where do you get started if this is new to you? Yeah,
I think an easy way to get started is if you have a website in the world that's publicly accessible, just run it through PageSpeed Insights. It's not perfect, but it gives you a really good idea of the big mistakes you might be making. And then using something like Core Web Vitals in the Trio tool, it's a really nice way to see how your performance is trending as measured by Google and how you compare to others. And then if you look at Web Page Test, one of the things you get is a waterfall chart of every resource that's loaded by the browser. And just look for things that are big, that are slowing down the whole page. And oftentimes it'll be a big uncompressed image, and it'll take a few minutes to take that image, run it through a tool like tinypng.com. Suddenly it gets 30% the original size, and your site gets faster.
Yeah, so it's really about sort of targeting that sort of low-hanging fruit. I think that's the same for accessibility and things as well. There's a whole bunch of stuff you can do fairly quickly, and then it's starting to look at the bigger things that might take a bit more development resources, I guess.
Yeah, exactly. And there's diminishing returns once you get those big low-hanging fruit out of the way. But then it gets really fun because you're starting to optimize small parts of the JavaScript and looking at server configurations.
Yeah. Cool. Well, that's brilliant. I think it's a really interesting talk. I think it's been a really good hour, and I think just loads of practical tips for people to take away. So thank you very much for that, and enjoy the rest of your day.
Brilliant. Thank you, Rachel. Thanks, Thomas.
Yeah. So thank you again, Simon, for the presentation. Thank you, Rachel, for co-hosting this session. We want to remind everyone watching the stream, if you like the session, please hit the YouTube like button, and follow up and subscribe to our group on youtube.com/inclusivedesign24. You can get notices about the upcoming presentations and also see a whole wealth of presentations from previous years. Also a reminder that our #ID24 group is a respectful community, and you can find our code of conduct on the Inclusive24 Design website. Also, this event is brought to you with thanks to our supporters. We couldn't do this event without them. Thank you to Intopia, Fable, TPGI Arc, Adobe, Tetralogical, Intuit, InfoAxia, the Center for Inclusive Design, Web Directions AAA, Adrian Roselli LLC, and Can I Access? Thank you to all those wonderful companies. We'll be back at the top of the hour with our next session. Stay tuned and we'll see you then.
Bye all.